Hey, welcome back. We're doing the Ultimate Go Tour, and in this Ultimate Go Tour, in this video, we're going to do some hands-on exercises with pointers. You could get to the Ultimate Go Tour by going to ardenlabs.com tour list, and there's a whole series of videos that I'm doing to accompany each of the steps in the tour here. We're learning, going deeper with the Go programming language and learning some great stuff. And it's good to reinforce all this and then also learn it if it's new to you. So if you click on pointers here, and then you come in here, when you get here, you have steps, and you have step 1 and step 2. So I'm going to click this little arrow right down here, step 2, go to step 2. And then here we have some exercises, and up here we have some tabs, exercise 1, answer 1, exercise 2, answer 2. And just FYI, if you click run and it doesn't run, the server is spooling up. So if I refresh this browser by hitting refresh up here, where's my big arrow? Give me my big arrow. It's not giving it to me. And I hit refresh, then go back up and say, hey, show me the solution for answer 1. I could click run, and it'll show me the solution to that. At the end of this video, I'm going to give you some more resources, including the code base, all the links to all the other videos. You can find the links to all the link to all of the playlists and all the videos down in the description down below, but also going to give you some coupons to a course. All right, so let's check this out. So I've copied these exercises into my editor here. And I have 2 windows open. I have a window on the right and a window on the left. And the window on the left is the exercise, and this is the terminal associated with the window on the left. And so if I do a print working directory, you can see that there is where I'm at on the window on the left. And if I do a print working directory on the right, so I'm just going to clear this out in PWD. Over on the right, you can see where I'm at over on the right. And so this is an example from the previous videos that I did. And we're going to talk about this in a minute. So the first step here is declare an integer variable with the variable of 20. And so when we're inside curly braces, inside a code block, we use the short declaration operator. And so the correct idiomatic way to do this is to say a is equal to 20. So we're declaring an integer variable with the value of 20. And so this variable a, we're declaring there is a variable a, and it's going to store a value of type int, and that value is 20. And this is a short declaration operator, so the compiler will infer at compile time, based upon the value that's being assigned, that the type of this variable, the type that this variable is going to store is an int. You might, and we could print that out, and my linter will stop complaining, so fumped print line and pass in the a, and there we go. So we printed that out. You might have read that, and you might have saw it like this. You might have heard it like var b int. So declare that there is a variable b that's going to store a value of type int, and then assign to that variable the value of 20. And so you might have read it like that, in which case that would have been, one way to do it. But my linter is telling me that I could do this all on one line, should merge variable declaration with assignment on next line. I'm just going to leave that in. So this is not the idiomatic way, not idiomatic, and the above is idiomatic, right? So I'll put this here, is idiomatic. And if that word's weird to you, is weird to me when I was younger. So idioms are patterns of speech. You could Google that, idiom, and it's like how people use language. And so idiomatic is like we are using the language the way the Go programming language was meant to be used. So that's the first step right there, is to declare an integer variable with the value of 20. And the next step is to display the address of and value of that variable. And so I'm going to display the address with fump.println. There's a couple of ways we could do that. And to see the address of some variable, we use the ampersand operator. And so there's the ampersand operator. And I'm also just going to put in here a little demarcation. And so I'll do println so we could just read the output a little bit better. And that will display the address variable. So now if I come down here and Command K, or you could type in clear if you're on Windows. I'm a recovering Windows user who's now on a Mac. Recovering Windows user. I'm going to do a go run main.go. And you can see here that I've got the address being printed out there. Another way we could print that address out is we could use format printing, printf. And with format printing, I'm going to use the format printing verb %p, and then // / and then pass in the address of A, and they'll print that address out. And so again, we're just going to see that address get printed right here. And so display the address of and value of the variable. So that's the next part, and I'll do another little demarcation here. So there's some cool shortcuts in VS Code, and one of the shortcuts, if you come in here, you click on this little gear and you go down here, you can look at the shortcuts. And so you could just come in here and you could say, you know, like cursor, and start seeing cursor shortcuts, or you could type in copy and you could see different copy shortcuts. And so one of the shortcuts is Option Shift, and it makes a copy, Option Shift down arrow, and then Option down arrow moves, right? And so that's a nice little shortcut that I like right there. So the next one is declare pointer variable of type int and assign the address of the integer variable above. And so the easy way to do this would just be C : equal, and then we're going to assign the address of A, right? And if I print that out, and now I could come down here and just print line and print out C, that's going to show me the address that's being stored there. And I could also do a funct.printf, and I could come in here and I could say, hey, I want to see the % type. I want to see the type of, you know, and I'll do a tab right there, and I want to see the type, and I also want to see the value, and then I'll do a new line, and I want to see that for C and C, right? So I want to see the type of C, and I also want to see the value. And now I'm going to run that, and so we'll take a look at that and see what comes out. So here we're down beneath the second demarcation right there, and print line C, we're printing out that address. So we took the address of A, which is also showing up right here, right? So that's where we printed the address of A twice right there. It shows up right there. And we took the address of A and we assigned it to C. And so when we print out C, it's printing out the same address. But when we look, like, you know, what is the type of C? C's type is a pointer to an int, right? Like the variable C stores a value, which is a pointer to an int. And a pointer to an int is the memory address where an int is stored. We're pointing towards the memory address. With that entry right here, that value, with that address, we're pointing towards the memory address where an int is stored. So it's a pointer to an int. And interestingly, this is interesting, we are storing this information in its own memory location. And so wrap your head around this, right? So, you know, a pointer, A right here is a pointer to an int, and we're storing that here. It's a memory address, and the type is pointer to an int. But we could come down here and we could say, hey, well, what is the address where this is being stored? And we could print that out. And so this is being stored, this is all being stored at this address for C, right? And what's being stored there is this address here. It's the address of A. And maybe this would make more sense if I switch this around, %t, and then that's just going to give more, I call it mental symmetry. So when you're learning to code, for me, mental symmetry makes things easier to read, because look, we could see now that these are all lining up. They're the same one. It's mental symmetry. It's easier to read, and that's all being stored at that location right there. And interestingly, if we look at the type of what that is, so if we bring that down and just, like, you know, exploring and playing around, like, okay, well, what is the type of that? And I'm going to do another little demarcation here, and so I'll make a copy of that and bring that down and put that right here. And I'll put here for the demarcation exploring C, right? And so we're really kind of just exploring C here. And so, you know, the variable C, not the language. And so here we're exploring C. And so the address where this stuff is being stored is right there. And as we explore C, right, so here again we're seeing the same thing that we saw there, which is the address. But then the type here, right, of that is a pointer to a pointer of an int. Because we took the address here of what is being stored at C. Well, what is being stored at C is a pointer to an int. So this is a pointer to a pointer of an int, which is interesting, isn't it? I'm just going to let you reflect upon that. And so you might have read this. You might have read the declare pointer of variable type int. And so I'm going to do another demarcation here, and I'm going to put nil here, right? And so you might have read this. And remember, a nil is the zero value of a pointer. And so we'll just do nil. Nil is the zero value of a pointer. And so you might have read this. You might have read declare a pointer variable of type int. You might have said, okay, and what are we at? C, we're at D. And so you might have said, all right, D is, going to be a variable. I'm declaring that there is a variable, and that variable has the identifier D, and it's going to store values of type pointer to an int, right? So you might have read that and said, okay, I'm going to do it like this. And then when you do that, you might have printed this out. And so if we print line that and we say, okay, show me the value of D, and then we run this, going to run this, right? What we get is nil, right? Because we have a pointer here, and it's a pointer to an int, and it's set to, you know, if we don't assign a value, the compiler assigns a value. And so if we haven't assigned a value to a pointer of an int, the 0 value gets assigned by the compiler to the pointer of the int, and that becomes nil. And then earlier over here in the previous video, I made a mistake. Maybe it was the hour early in the morning or something like that. And when I printed all this out over here, and just to see this run, go run main.go, we got this address right here because I used fumped printing, and I said, hey, print out the address of that. And I forgot to put in the ampersand right there. And so that would have actually given us the address, right, where this nil value hasn't been initialized, nothing's been assigned, but that address is there. That would have given us the address. And so again, if we do that same thing right here, and I could just, well, I'll copy this line of code right here, so bring it down right there. And if I change this to putting in D right here, right, and let's take a look to see what that prints out. So I'm going to go like that and run that. And so here, when I print that out, right, it says, hey, nil is this value right there. And again, that value is nil, and it's a pointer to an int. And if I want to change this from %v to see the address, I could do %p right there. And so I'm going to take a look at what that %p is, and it's going to be 0x0. And I was like, you know, you see, there's no memory address yet. And there is a memory address. I just had forgotten to put that ampersand in. It's the way it goes. You write the code with errors before you write the code without errors. So if I run this again, I see that memory address. So it's been declared. There's a memory address, and it just has not yet been initialized because nothing's been assigned to it. And because nothing's been assigned to it, the 0 value of a pointer is nil. And so that's why we still have nil right there. And so if we wanted to then like say, okay, hey, at D, right? So D, the type of D is a pointer to an int. We could see that right here, the type of D right there, the type is a pointer to an int. I'm going to dereference that. So I'm going to use the dereference operator, and I'm going to set that to a pointer to an int. So I want to store a value there, which is a pointer to an int. And I want to store the value of A there. So if I do that, and then like, hey, I'm going to print that out when I'm all done, and just look at like what is the value that I stored in D, which is a pointer to an int. So I'm dereferencing that. It's a pointer to an int, right? I've got D. It's a pointer to an int. I want to dereference it, and I want to store. If I dereference it, I just have to think this through for a second. So I have a pointer to an int. D is a pointer to an int. And so if I'm going to store an address there, I could do it like that. But if I want to store the value, right, of what that address is pointing to, I could change it like this, right? And I can make that 21. But that's going to be a pointer dereference, nil pointer dereference error. And so let's just take a look at that. I'm going to run that, and I get this error, invalid memory address or nil pointer dereference. And so let's see if we did this and we did D, and then we put in the address for A right here. And let's see what the compiler tells us on that. And the compiler is okay with that, right? Because we have D, it's initialized, it's a variable D is declared to store a value of pointer to an int. And then here we are assigning a value, and so that's initializing it. Right? But we couldn't dereference it yet because nothing was stored in there. But now that something is stored in there, we could do this again and bring this down. And now we could dereference D, and we could see what value is stored in there. So this pointer stuff, even after time, it takes some thinking through. And so the address, right? If we look at line 47, so where's A's address? Because we assigned A's address right here to D. And so here's A's address 110018. And then down here again, right, we assigned that to D, A's address, and we printed that out. And here's 110018, right? And so we have A's address there. And this one right here is the address where D is storing its information. And then the value, when we dereference that value, right, the value that's stored at that address, which is this address right here, is 20. And so interestingly, now that we have, right, now that we've stored some value there, that address, which is a pointer to an int, we could dereference that address and we could say 21. And then check this out, func.println, and we'll print out A. And then, you know, so A is the original one up here. And then B, we didn't assign A to B, but we did assign A to C, right? And so C is like pointing to the memory address. And we also assigned A to D. So we could print this out and we could do C here, and we could do D here, and we could do C here, and we could do D here. And they're all going, even though I'm changing only D right here, I'm changing that memory address, right? And so all of them are going to reflect 21. And so here's A is 21, but C is a memory address. So I'm going to dereference that to get the value. I'm going to dereference that to get the value. And when I dereference those, and these are now the address of A. So you can see that those have the address of A stored, but when I dereference them to see the value, I'm going to run this once more. They're all 21. And so that's like, you know, just kind of thinking through pointers and using the, you know, ampersand operator and the dereference operator, and, you know, and just playing with that. And so the last step in this challenge here is display the address of, value of, and then value the pointer points to, right? So we want to display the address of A. We've already done that. And, but, you know, just for good measure. So display, we'll display A, and then we'll display the address of A. And so this is like, you know, display the value of is the way I read that. And so the value of A is that. And so we'll put in another little demarcation here and bring this down. And, you know, final, and this will be the final one. Final one right here. So the value of A, that's what the value of A is. And the address of A, so the address of A will be this. Address of A, and let's look at those two, and then we'll see, because that last comment, last instruction kind of was like, I was confused by it. And so the value of A is this, and the address of A is this. And so we have the address of A, the value of A, and the value the pointer points to. So declare a pointer variable of type int. So maybe they wanted us to do this with like C, the C variable. So here's the value of C. So the value of C is that. So let's do that. And then the address of C is this. And so I'm going to, that's probably what the instruction wanted. So there is the value of C is this 0018. And that 0018 is like, you know, the address of A. And so that's what we stored in C. And where that is stored for C is in this address. And then, so that's the address of, the value of, and the value the pointer points to. So the value the pointer points to is we're going to have this, the value the pointer points to is we're going to have this one, right? It's that address. And let me bring that back up and bring it down. And so what's stored at that location is the address where A stored its value, which is 20, but we've changed it to 21. And so to dereference that address right there and see the value there, we use that operator. And now I'm going to run that. And if that's not a PhD dissertation, I don't know what is, right? Like we took something and we talked about it for 19 minutes. Man, that's a hazard of the occupation in academia, is like you take one little thing and just keep exploring it and parsing it and looking it through. But hey, that gives us a lot of knowledge. This was a good exercise, good practice. In the next video, we're going to go through the second exercise here. This was the first exercise, so we'll go through the second exercise. If you want to deepen your knowledge with Go, if you want, we have this entire code base. So you could go here to Goes to 11, then click on repositories, and you could click on Learn to Code Go version 3. And then in here, you could scroll down to 000BR. And so here's the 000BR BK Go Tour. And I have this README here, and then each of these READMEs will take you into these folders where they each have a README. And so like here is the README for this entire section on pointers. And like there are all these takeaways and a table of contents with additional reading to grow your skills. And there's Blaise Pascal and a quote from Blaise Pascal, and then this code review check, which is super important. And then there are coupons for courses. So you could click this link here to take my courses. It'll give you a special price. And you could also click this link here to take Bill Kennedy's courses. And so my courses are like beginner to intermediate with some advanced. Bill Kennedy's are intermediate to advanced. And so you could check them out and see which ones are right for you. Mine are like, like less than $15 USD usually, and Bill Kennedy's are usually a bit more than that. And if you open up this link for Bill Kennedy's course, you could come in here and you could click have a discount code, and you could type in my name, Todd McLeod, and you'll get a special discount. It's a surprise. And then also if you know that is still a little bit too much for you, you could come back here to the Ultimate Go Tour. And on step 1 of all these steps, Bill put in this thing, need financial assistance. So you could click that and fill out the scholarship form. And I know that Bill, I've seen him help a tremendous amount of people. I know that like if you're like, hey, I'm in this country and like, $10 USD is like my day's wage. Can I pay you $3? He'll be like, sure. Or he'll probably just be like at that point, go take it for free. All right, so that's playing with pointers. And I hope you enjoyed that. If you did, hit that like button, hit subscribe. There's more videos coming. Check out the links down below in the description, and I will see you next time.